Welcome to Lecture 2.5, Addition and Subtraction of Fractions. So the first step, we're going to look at this a very interesting way. If you remember your distributive property, we're going to consider the distributive property as in A times the quantity B plus C equals A times B plus A times C. So how can we apply this to adding and subtracting fractions? Let's consider 2 over 7 plus 3 over 7. So 2 over 7, we can break it down into 2 times 1/7, and 3/7, we can break it down into 3 times 1/7. Well, lo and behold, they each have a 1/7 in common. So using our distributive property, we can rewrite the problem as 2 times 1/7 plus 3 times 1/7, which is another way of saying 2 plus 3 times 1/7. 2 plus 3 is 5. 5 times 1/7 is 5/7. So that worked out really great if the two fractions have the same denominator. So the rule is, if the two fractions have the same denominator, all we need to do is add their numerators to get the numerator of the answer, and we keep the denominator in the answer the same as the denominator in the original fraction. So, for example, for addition and subtraction of fractions, if A, B, and C are numbers and C does not equal 0, then A over C plus B over C equals A plus B all over C. Likewise, A over C minus B over C, we end up with A minus B all over C. So let's take that rule into consideration and try a problem of 3/8 plus 1/8. Denominators are the same, so I keep my denominator and I add my numerators. So 3 plus 1 is 4/8, but 4/8 can reduce. 4 goes into 8 2 times, so my result is 1/2. Let's try another problem. 9/5 minus 3/5. Again, the denominators are the same, so I'm going to keep my denominator and I'm going to do the math in the numerator. So 9 minus 3 is 6. So the answer is 6/5. Let's try one more. So 3/7 plus 2/7 plus 9/7. They're all over 7. So I keep the denominator. That becomes 3 plus 2 plus 9. 3 plus 2 is 5. 5 plus 9 is 14 over 7, and again it can reduce to the number 2. So now we need to talk about some vocabulary. The least common denominator, the LCD. For a set of denominators, the LCD is the smallest number that is divisible by each denominator. So you may have heard this be called the least common divisor as well as the least common multiple. I'm generally just going to call it the LCD, so least common denominator or least common divisor. So LCD. Using the LCD we want to find for 5/12 over 7/18. Now, right now, we cannot combine, at least in terms of adding and subtracting, the two fractions because they have different denominators. So the first thing we need to find is the LCD. So for 12, 12 is 2 times 6, but 6 can be broken down into 2 times 2 times 3, so 12 is 2 times 2 times 3. 18 is 2 times 9, or 2 times 3 times 3. To find the LCD, I line them up to where they're kind of on top of each other. I need a 2. I need a 2. I need the 3 that they have in common and the 3 that they don't have in common. So the 2 that they don't have in common, the 2 they do have in common, the 3 they have in common, and the 3 they don't have in common. So 2 times 2 times 3 times 3 is 36. So the LCD between 12 and 18 is going to be 36. Now why did I figure that out? Because now I'm going to use 36 as the denominator and change each denominator into 36. So 12 times 3 is 36, and 18 times 2 is 36. So I can add the two fractions as long as the denominators are the same. So by changing the 12 to look like a 36 and changing the 18 to look like a 36, then I can add the two fractions. But what I do to the denominator, I have to do to the numerator. So 12 times 3 will get me 36, but I must multiply the numerator by 3 as well. So 5 times 3 is 15. 18 times 2 will get me 36. And then I have to multiply the numerator by 2. So 7 times 2 is 14. Now I have two fractions that have the same denominator. And now I can add them together. So 1536 plus 1436 equals 2936. That's my solution, 2936. Okay, so here's an example. We're going to find the LCD for 3/4 and 1/6, probably because we're going to do some math here in a little bit. So 4 is 2 times 2, and 6 is 2 times 3. So my LCD is going to be the 2 they don't have in common, the 2 they do, as well as the 3 they don't have in common. So 2 times 2 is 4, times 3 is 12. So off to the side I'm going to say 4 times 3 is 12, and 6 times 2 is 12. Okay, just keep that in mind. Now I want to add my fractions. But before I can add my fractions, they have to have the same denominator. So 3, 4, well, I can make it look like a 12 on the denominator, as well as 1/6. I can make the 12 in the denominator. So to get to 12, I multiplied by 3. 4 times 3 gives me 12. What I do to the denominator, I must do to the numerator. So 3 times 3 is 9. 6 times 2 got me the 12. So 1 times 2 is 2. Now I can add 9/12 plus 2/12 for my result of 11/12. Okay, so my end result is 11/12. I want to subtract 7/15 minus 3/10. The first thing I need to do, because the denominators are not the same, find the LCD. So the LCD of 15 will be 3 times 5, or 15 is 3 times 5, and 10 is 2 times 5. So the LCD, they both have a 5, but I need the 2 and I need a 3. So 2 times 3 times 5. 2 times 3 is 6, times 5 is 30. So 15 times 2 equals 30, and 10 times 3 equals 30. So now I'm going to change my fractions. So, pardon me, 7 over 15 I multiplied 15 by 2 to get to 30. So what I do to the denominator, I must do to the numerator. 7 times 2 is 14, and 3 over 10, 10, I multiplied by 3 to get to 30. 3 times 3 is 9. So my new problem is 1430 minus 9 over 30. 14 minus 9 is 5 over 30. But 5 over 30 will reduce down to 1/6. So my end result is 1 over 6. So think about the steps when we add or subtract any two fractions. The first step is if they don't have the same denominator, we need to factor each denominator completely and use the factors to find the LCD. Then step 2 is we're going to rewrite the fraction with the LCD as the denominator, and whatever we multiply the original denominator by, we must multiply the numerator by. Once we have the same denominator amount, we can add or subtract the numerators, and then we reduce the fraction to its lowest terms. So just 4 steps. Can be a little lengthy, but just 4 steps. Now let's try several examples, and I'm going to move through these pretty quickly. So I can see that 5 is a prime number, and 5 is not in 6. Okay, so that's 2 times 3. So my LCD must be 2 times 3 times 5. Right? They have nothing in common, so it's going to be 5 times 6, which is 30. I'm going to rewrite the numerator. So 3/5 is going to be 5 times 6 is 30, 3 times 6 is 18, 1/6, 30. 5 times 6 is 30, 5 times 1 is 5. Now I'm going to subtract 18/30 minus 5 over 30, 13 over 30. And that's my end result. I can't reduce. Right? Same thing if we have 3 fractions. I still have to find the LCD. So the LCD is going to be 6 breaks down into 2 times 3. 8 breaks down into 2 times 2 times 2. 4 breaks down into 2 times 2. Another way of looking at this is 2 times 3, 2 cubed, and 2 squared. The most 2's I have is 2 cubed, so I must use all 2 cubed. And then I have 1, 3. So I must use the 3. Okay? 2 times 2 is 8, times 3 is 24. So the LCD is 24. I'm going to quickly rewrite all of the fractions with the LCD of 24. And 1 over 4 equals, I jumped the gun there, 6 over 24. So 4 plus 3 is 7, plus 6 is 13. So the end result is 13 over 24. So this is end of part 1 of this lecture. We'll pick up more examples and continue with fractions in our next video. So until then, be seeing you.